All right, folks, I'm going to claim my 50 minutes of time here. So first things first, if you haven't finished the mid-semester survey that was in lab yesterday, please flash that QR code and fill that out, please, and thank you. All right, so today, I'll do just the standard reminder, mark yourself here in Blackboard, which goes to EdStem for attendance, please. We're going to move on to functions. So functions are not going to be on the exam, almost like a little over a week from now. So we're going to do this today. We're going to do this Monday. We're going to do this Wednesday, and then we'll do the exam prep on Friday, and then we'll get back into functions again. So today's agenda, we are going to look at what are called user-defined functions. And you know a whole bunch of functions already, so we'll go through some of those. And we'll talk about the reasons that we have functions. Loosely, these are the sections in ZyBook that we're going to cover today. The lectures, again, they're not one-to-one mapped to what's in ZyBooks. I try to cover the same topics, but if anybody looked at chapter 7 so far, it's like 17 sections. It's huge. So I'll try to be very specific as to which sections I'm covering, just so you can stay oriented a bit. With respect to due dates for homeworks and labs for 7, don't worry, they're going to be pushed out beyond the exam. So they're not going to be due, but we are going to do the functions lab next Thursday. But don't worry, I'm not going to grade it for well after the exam. So if you have to prioritize catch up on branching, loops, and strings, you should have an appreciation from this lecture what's going on in functions. So if you didn't get ZyBooks, not a huge deal, but we will get back to that in earnest after the exam. Okay, so does anybody like Joe Rogan? Yeah. I was a fan of Joe Rogan in the 90s when he was like a traveling comedian out of the back of his car in Philadelphia. He was awesome. There's a great bit on here. I think it's actually, I reminded myself, it's actually a little bit too raunchy to watch in class, so I'll caveat if you want to watch it, but it's a really good little bit that will give you a very strong appreciation for functions. So if you like Rogan, check it out. But fundamentally, how do functions work? How do they work? Maybe they're just magic. That's the whole part of the Rogan bit in there. So what is a function conceptually? How should we think about a function, right? So we know some functions already. We know length, we know print, we know input, we know strings, we know int, right? Fundamentally, you can think of a function as basically a machine. It's something that takes some inputs. You're not entirely sure how it does it, but it does something and it spits something out. So a sandwich making machine might take lettuce and tomatoes and meat and bread and whatever. You as a human would know how to make a sandwich. I don't know if I could envision how a machine might make a sandwich. Maybe I have some ideas. But suffice it to say, we see machines like this all the time in everyday life. Given the same set of inputs, right, we can use different machines to manipulate them. So instead of a sandwich making machine, we can have a taco making machine. That's going to take materially the same ingredients, right? It's going to do something different than how you make a sandwich, but it's going to spit out something different as well, right? So the parts to a function, these are the key parts to a function. There's inputs. You give it something. Something is done. There's some task. We do stuff. And we get outputs. Something comes out the back. Another metaphor, another way to look at this would be if you were parking at the parking deck here. So if you're going to park at the parking deck, presumably you have some sort of ticket. You literally insert it into a machine in most cases, right? So it's input. You're putting your ticket in the machine. The machine is looking at your ticket. It's determining, okay, well, when did you come into the garage? It's looking at the current time and it's calculating a price. So it's doing stuff. And then there's outputs. And outputs could be different things. It could be just printing something on the screen, right? Or it could be, you know, interacting with the payment system, so you have to put your credit card in, right? So that's conceptually what we mean by functions, right? And again, as a reminder, a function, we've seen this over and over and over again. We've seen length, we've seen print, we've seen string, we've seen int, we've seen enumerate, right? I can't list them all out. But they really follow the same pattern, whether you're going to write that function or whether Python's going to write that function. And if you so choose, you could write your own length function, len. You could write your own print function. You could write your own input function. Go ahead and do it. I actually do that for the unit tests, right? For the unit tests, I write my own function to act as input. So rather than a human having to test all of your assignments in code, right? I wrote a bot, I wrote a little bit of code that injects stuff. It pretends somebody's typing at the keyboard. All right. I really hope at this point, this pattern is becoming super familiar. We've seen this with branches. We've seen it with loops. I said we were going to see it with functions, so here it is. So for a function, we have the keyword def. What other keywords have we seen similar to this before? I just rattled a whole bunch of them off. For, while, if, else, else if, right? Those are all keywords, right? So follow the same pattern. A little different than those examples. Here I don't have a conditional, but I just have a function name. Whatever I want to call my function. If I was going to create the length function, I would say def, L-E-N. Then we have a set of parameters that are inside of parentheses, right? I still see people kind of making this mistake every now and then. It's got to become sort of second nature. When you're dealing with a function called input, when I say read, X from input, we got to stop doing that. We have to remember to do that all the time. All right. Then there's the colon. And the colon coupled with this indentation lets the interpreter know, hey, you need to treat all of this stuff here, this code block, in isolation from everything else going on in the program, right? So when we have an if statement, right, that's why we indented everything in, right? Sure, it made everything look kind of pretty, but it was also the way we knew I only want to increment it if count is greater than 9. I only want to replace the previous character if, it's different than the previous character, right? This is going to be my favorite thing. From the class's uptick on doing documentation, I'm questioning if y'all are going to do this so much, but I've been enforcing everyone to do descriptions, to add comments to your code. This is relatively enforced in Python. It's not required, but I'm going to require it. Every time we write a function, we have to put what looks like a comment here. And that comment, you can actually programmatically call it later on. Later on, you can call it so that if I give my function to you, you can say like help function name, and it will tell you what that function does. The guts of what we do inside a function, again, it goes indented here, but that's where the magic happens. So like in my sandwich machine metaphor, that's where you say, take 2 slices of bread out of the bag, take the mustard off the shelf, cut the tomato, put the lettuce on, put a slice of meat on, right? That's where you do all those metaphorical steps. And you can put conditionals in there, so if blocks, you can put for loops, you can call other functions, a whole bunch of stuff you can do there. Anywhere in the code, but usually it's the last thing in your code block, you can return something. So you could calculate somebody's age, or you can concatenate a string, or whatever it happens to be. You can return it. You can say, hey, now that I'm leaving this function, just like I would be leaving like a while loop or something, here's a value. Okay. This is probably the simplest function. Well, maybe not the simplest, but it's a pretty simple function. This is a function I created called greet, right? So greet, it has the same things we just looked at. It has the keyword def. It has the name, so I call this function greet. It's going to take a parameter called name. It has the colon and the indentation. It has my doc string, so people know what it does. And then this is the magic. This is what my function does. This shouldn't be foreign to anyone, right? All I'm doing is printing out hello with a space and the name that's passed to me. There's no return statement in this, but we'll see that in a second. Here's a very similar function. So where that last function was just greet, this one is get time-based greeting. And just very simply, I want to say, if the time is less than noon, I want to say good morning. Otherwise, I want to say hello. So here, I have a function with a keyword. I have my function name. I have my parameters, the colon, and this indentation to say all this stuff. When someone's, and you'll see how I call a function in a minute. When someone calls this function, do all of these things. So again, we're kind of, stitching things together here. Everybody knows how to do concatenation of strings. Everybody knows how to assign variables. Everybody knows how to do branches here, right? So all this stuff now we're just using it in concert with functions. Okay. So just as a recap, what I was hinting at on the board up there, how do we call a function? Well, this is what y'all know today. So we know we have the function int, input, and print. Even when you use the IDE, right? When you're typing like EdStem or whatever, you start typing input, a lot of times it just puts the parentheses in for you, or it puts the quotes in for you, that sort of stuff, right? So that's obviously a function. That's how I call it, right? The thing that I put in there, we call that an argument. So an argument is what we put into a function. So this is int, I put the string 6 as an argument. Input, I have the prompt name. Print, I put in some float value here. Does every function need to have a parameter? No. Hopefully y'all got that little annoying trick in assignment 5. You have to like pepper it with like print statements all over the place. If you haven't caught on to that yet, if you just write a print statement like that, it effectively gives you a new line. That might save you a lot of toil if you're like, your unit tests aren't passing, you're like, mine looks exactly like that. You're like, oh, no, I'm missing a new line, right? So yeah, we've seen that with input, right? We can have that optional prompt. It's really annoying when we don't have that prompt. It's really annoying when Zybooks, says, hey, get a int from input, and you're sitting there like, what the hell's going on? And you forget, oh, shoot, I need to type something. We will get to this in November. We will talk about something called classes, but you've already sort of seen these. I've used the term method. Method is basically a function, but the way you call a method is you have an object. So we just learned this in chapter 6. So I have a string variable, my string. I could call split with that. What is that going to do? What's that function going to do? Yeah, it's going to give me a list with 2 elements. Thing at index 0 is my, the thing at index 1 is string. And then my string is all num is going to check if it's alphanumeric characters. So These are technically functions, but you can't just call like is all num on its own. It doesn't make sense. You can't call split on its own, right? You might feel tempted to do like split and pass my string into it, but then you don't have the delimiter, right? So those are methods. We will get to those a little bit later in the semester. As I mentioned, the things that we put into a function, they're called arguments, right? And I mean, pretty simply, we just saw that. You put it inside the parentheses, and functions can take 0, they can take 1, they can take 1,000 parameters. I'm going to show you later on, not today, how to do optional parameters, right? So obviously, input, there's an optional parameter. A lot of times when you use the IDE, you'll see it kind of pencils in there prompt, right? You don't have to put a prompt in, but it makes the code a little bit easier to use. If you want to be a really good computer scientist, you need to know the difference between an argument and a parameter. And I can guarantee you, if you nail this, you will walk into sophomore year and you will probably look very smart to whoever is teaching next year's computer science courses, because they're going to screw this up, because everybody kind of screws this up. This is covered in Zybooks, but it is very important. Can you be a good coder and not know the difference? Absolutely. You can code stuff and never know the difference between an argument and a parameter. But this is the difference between speaking highly intelligently as a computer scientist and just speaking as somebody who knows how to code. I will probably screw this up every now and then, but when I have a function, when I call that function, when I call greet, the actual value that I put in, we term that argument. That's the argument. The function, this variable here, is the parameter. So we pass an argument into a function that has a parameter. If you want a little mnemonic cheat sheet for this, argument A, actual value. Parameter P, placeholder. So name, I think we can all agree, I probably wouldn't have a program that would print hello name. Likely I'm printing hello Dan, right? So if you just kind of remember that mnemonic, argument A is the actual value, parameter P is the placeholder. This is one of those things that A, you'll look smart, but B, at some point in time as you progress in your computer science career, this will become invaluable. If you ever get to the point where you might be writing your own programming languages, which, by the way, you should be doing that at some point in your college career, that will help tremendously. Okay, so how do we call a function? This should be relatively brief. We know how to call print. Print with the parameter hello world. Well, hello world is the argument. It takes a parameter called string or something. Float with the argument 100. I can assign a value. This function returns me something. Input, we use the keyboard, we ask for something with the argument name. Right? So these examples that I introduced, and we will get to the actual coding bit in a real quick minute. I defined this about 5 minutes ago. How do I call greet? Much like how did I call length? How did I call print? Well, once this function exists, it's as simple as that. I just use the function name. So I say greet, open parentheses, and if it takes a parameter, I put the parameter in. So greet Dan, the flow of execution will come in here, and it will take, oh, I have name. I will format this string to say hello Dan. In fact, if that's wrong, it should actually say hello, comma Dan. But we'll fix that in post-production. Here is that other function. Here's a function that takes two parameters, and this time I have a return value. So how do I call it? Greet. Well, that's screwed up too. That should say get time greeting with Dan and 11, right? I was too busy focusing on the fact to remind you that, hey, I can embed, right, my function inside another function. This is like no different than when we did this stuff, when we did x equals int input, right? I can put my function inside of a function. Okay. I mentioned a function can return something. So something like length returns the length of whatever you put into it, right? But not every function has to return something. What's a function that doesn't return something that we know? How about print? Print literally puts something to the screen, right? But you can't do y equals print name. I mean, technically you can, and you'll see this in a little bit. This will return you a value called none, which some of you have seen in assignment 5. But that doesn't make sense typically, right? Print is not going to return you what it's actually printing to the screen. So not all functions have to return something. So in this example, I have one return at the bottom. A function is not limited to just having one return statement. You can have as many as you want. With respects to what we saw with loops, what does that kind of look like? What's that? That's not a loop, that's a conditional. If I wanted to get out of a loop, what would I do? Break, right? It's kind of like a break statement. It's basically saying, hey, wherever I am in this code block, stop what I'm doing. The difference between a break and a return statement is a return statement will typically give you something back. So here it's giving me back that string. And as I mentioned, not all functions, like the print function, you don't need to return something. So I have a function here that's just going to print out this message. So I'm not going to return anything. It's going to do all the work for me. My friends who know Java, what's the way you create the basic Java class? Does public static void main mean anything to anybody? So public static void main, the word void. Void means don't return something. Just be, just do. Okay, so we're going to jump into EdStem. I think, and pardon, if you want to do the code, I don't think I put it in Blackboard just yet. But if you go into EdStem, just go into EdStem, find section 7. Lecture slides are here, and you can open up assignment 7. So let's say the len function didn't exist. If we wanted to write it ourselves, how would I write the len function for, let's just say, strings? Huh? Well, let's say I didn't have functions. Let's say I wanted to do the logically, how would I implement the length function? A for loop. I heard you, a for loop, right? So if I wanted to implement the for loop, and I think we've all done this a whole bunch, right? I would just say, let's say, the string I'm going to get, what string? I would do, if I didn't have the len function, right? I would say for C in string, and I need to accumulate this thing. So let me keep a count. Count equals 0. I would say count plus equals 1. And then I can say, simulating len, my string, what is it? String adds length. Count. What string? Dan. Dan has length 3. And F has length 4. So, what is the magic that's going on inside len? Well, let's implement it. Okay. Using the basic syntax we just learned for functions, write a function. I'm just going to call it my_len. We can call it len if we want. That takes a string as a parameter and returns the number of characters in the string. So my function definition starts out with def for definition. My len, and I want to take a parameter s. Now my IDE knows what I want already, right? It gave me a code block. What do I always say? We're kind of lazy. I'm going to take this logic and just paste it in here. Just make sure I get my indentation right. Say return count. And now here, if I want to invoke my function, string to get the length of, Yeti. Uh-oh, 4C in string. What did I do wrong? Well, I don't have something called string. I have something called S now. Okay, let's use that. Oops. What string do I want to get the length of? Yeti. Yeti has length 5 from my len function. Okay. Now, let's take a look what's going on here, because it might be a little confusing that the sequence of execution, everything you know up to date, right? I've been saying the interpreter reads stuff and it executes line, 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 right? It actually couldn't do anything here yet because it didn't know what S was, right? So I'm going to flip over to this Python tutor thing that we had looked at before. Okay? So this is the same code. So this is what the interpreter does. So the interpreter takes this file and it goes line by line by line by line by line. Okay? So the first line of my program here, actually, let me go back to the beginning here. The first line of my program here, the interpreter says def. It's saying, yo, Dan, you're defining a function here. All right, let me bring this back. It's saying you're defining something called mylen. So what it did was, in Python, it's slightly different than statically typed languages like Java, mylen is a function. It's an object. So it's just sitting there in memory. It's not doing anything. This is the first line of code that's actually going to do something, line 7 here. So it's waiting for my input, string to get the length of. Let's do that Yeti example again. Okay. So now my string variable, right, lives in memory with the value Yeti. Now I hit this line, 8. L equals mylen, my string. The interpreter goes, where is mylen? And it goes, ooh, I know. I bet there's a variable out here called mylen. Let me go find it. It's kind of doing the same thing had that just been len. The interpreter is going, yo, I know somewhere out there there's a function called len in some, it's not the global frame, but we'll learn more about framing later. So look at where the flow of execution went. So now the interpreter said, okay, I know my len is a function, so I'm going to go up here. I was given the argument Yeti, and I have the parameter placeholder s. Now it's going to execute this code. It's executing this for loop. Yeti has whatever, 5 characters. You can see count is increasing. You can see what character I'm currently looking at. Okay, I'm on that last character. I come to the top of my loop. I exit the loop. So now I have return count. So count has the value 5. This gives me a little tip to say, I'm going to return 5. And now the flow of executions, it finished my len. It comes down here. So prints it out to the screen. String to get the length of Yeti. Yeti has length 5 from my len. Okay. Okay. So let's build another function. Calling a function inline. Pass the result of our function into an expression by creating a variable slen plus 10 and setting it equal to the length of our string plus 10. Show in the print what was inputted. Okay. So let me give us this function back. So I'm going to ask the user for a length. Let's get rid of this noise here. So there's my function. I'm going to ask the user for some string. I'm going to calculate the length. Let me create a new variable, slen plus 10. Just take this out of here. Let's see what that does. Yeti. Length of Yeti plus 10 is 15. Oops, let me make a little space there. Length of Yeti plus 10 is 15. Okay, the math seems to check out there, right? So again, this shouldn't be too foreign. I've seen y'all doing this already with like just the regular length function, right? So what's kind of nice about this is, you know, if I wanted to baby step this, and hint, hint, this might come in handy when we do some of the quizzes, especially the strings quizzes. I could just do this, right? I could like just break it up. That's the same thing. Length of golf plus 10 is 14, right? So I can break stuff up like that. And what's good about breaking up the stuff like this is if I needed to use this length later on in the code, I have it. But if I don't need it, right, one of the sort of downsides here is if I really like packed all this stuff in, I could take that whole expression and I can just jam it in here, right? Now if I do golf there, you know, I still get the same answer. I get the same result, but I don't have access to what the length of that string was. So there's nothing wrong with doing this. If you know in your code, hey, I'm never going to need those interim variables again, yeah, just do that. That'll be cool. All right, let's move it on down. Multiple parameters in a print statement. So enhance the mylen function such that it prints out every I characters. Name it mylen with print function. Okay. So, not joking, lazy programmer. I'm going to grab the function I already wrote, paste it, rename it mylen with print. Prints out every I characters. Okay. So first I'm going to need a parameter I. And in here I can say if if count mod I equals 0. So if they give me 2, 4, 6, 8, those are the characters I'll print out. If they give me 3, 3, 6, 9, 12, those are the characters I'll print out. Okay. Let's call our function here. And I'm going to take my string. Let me just put the number 2 in. Okay, let's run that up. String to get the length of. I don't know why I'm on Yetis today. I think I saw somebody's thermos. So Yeti printed out character 0, character 2, character 4. And then, right, it returned the count, so I could use it down here in this statement. Okay. So developing these functions is pretty darn easy. Just cut and paste in a lot of cases. You won't be able to see the source code for like the actual length function. I know this sounds kind of weird, but the length function in Python is actually written in C. And it's written in C, so it can be super efficient. So C is used in a lot of, I don't know, like high frequency like applications, used for a lot of AI stuff. So it's ironic, you're using a programming language that's actually implemented in another programming language. Not too uncommon. Okay, last example here, create a function that does not return a value. Basically the previous function, but no return, call it mylen with no return, whatever. So let me take this function, I'm gonna paste it down here. I'm gonna take this string I had here. Instead of returning a value, I'm gonna say, be careful with my variable names here, or my parameter name to be more specific. This is now S. I don't have something called L, I have something called count. Maybe I'll put my message here from inside. Now I still need to ask the user for their input. I'll call this function here, pass in my string. This time around, if I want to ask the user my it or whatever I want to call it, I can just say int input. I'm not going to be nice. I'm not going to put a prompt in there. Let's run that up. Put in camera. Oh, yeah, that's right. I didn't put a prompt in there. That sucks. Let's say every third character. Cool. So I had this interim print statement here. So, and then I printed out, okay, every third character. I guess that was C and E. And then I have this message. Camera has length 6 from inside. Now, take a close look at this. Remember how I said print, if you called y equals print name, you would get none? Pay attention when I call here mylen with print function. I don't have a return statement anywhere in here. Since I don't have a return statement, this printed out camera has len none. That's what a function that doesn't have a return prints. It's kind of a nice feature in Python. Like other programming languages would error out if you did that. So kind of nice of Python to do that for you. Okay. All right, so that's the basics of strings or functions. So why do we want these functions? And again, functions are a big deal in coding. So number one, it makes the code more readable. I can sort of sequester logic in one place. So instead of having a program that's like 5,000 lines long, I could chop it up. Where can I chop up the program? Where can I put my other functions? What did we learn? What's that? Modules. Yeah, so I can create like another file and I can import it, right? So just like we had to import the math function. If you take a look inside the math module, you're only going to see math functions. If you look inside the random module, you only see random functions. So if you want to create, a module called songs, like the thing I've been doing a couple of times, you can start putting your own functions in there, and then you can use the songs module all over this place. That's that sort of point of modular program development. A lot of times, the software we write is humongous. So one developer is going to be writing one bit of code, another developer is going to be writing another bit of code, another developer is going to write another bit of code, and then we're going to put it all together to do something big, right? It also avoids writing redundant code. I think we had that lesson. We keep learning that lesson over and over again. Like in the beginning, I had y'all writing like a lot of print statements, and then I said, well, let's use a loop, right? So we didn't have to write like 5,000 print statements. We could just do a for loop that went from a range 0 to 5,000, something like that. Updating code does not require other code. That's something that I've experienced over and over again. One of the biggest places this hit me under the second George Bush. I don't think it was like his decision, but daylight savings time moved. They moved it. I even forget which way. They moved it a couple months forward or a couple months back. And if you had code, you had to if you had like a time modules in it, you'd say, hey, I'm the stock market. The stock market opens at 5:30 a.m. or whatever it is. You had to rewrite your code because 5:30 a.m. was no longer 5:30 a.m. on April 1st because they shifted the daylight savings time. And so most programming languages at that point in time had time modules. So, a standard would be published, and whoever managed that module or whatever it was, that library, they would say, hey, we have now version 2 of our library. Start using that come April 1st. All right. So why functions? There's one. Someone's going to ask me why functions. I guarantee it. So. All right. All right. So that's what we learned. Homework. So again, if you can prioritize it, homework 7. I'm likely to jump around, like I said, a little bit. I'll do function arguments because we started talking about arguments. There's a lot more to that story. What are the due dates? So again, tonight, homework 6 and lab 6. Those will be graded. I think if the timer goes off at midnight. I think 11:59. Assignment 5 is due as well. I think EdSTEM will shut that down around 11. On Monday, we will be doing quiz 6 on the strings. The TAs took the quizzes. They gave it a thumbs up. Is a fair test. Wednesday, please don't wait till the last minute on assignment 5. Assignment 6 is going to be due. We need to get that in so I can get it back to you before the weekend. So you have it to prepare for the Monday exam. All right, have a good weekend, everybody. I don't know. I don't think Minor is like smart, like 4 hours. You can like ask it. What's up stuff? What?